Meet everyone. My name is Ryan Gutwein. I'm with Ignyte Assurance Platform. I'm one of the co-founders, managing directors. We're going to be talking about securing the future, Kubernetes adoption in regulated environments. So really the purpose of this presentation is going to be how we bridge the gap between developers and auditors. Can be internal auditors, can be external auditors, because let's be honest, they don't really understand the technology. And so for this, it's going to be really showing how we bridge the gap between developers and information assurance professionals. So a little bit intro into me. So I was an Air Force security forces operator, tactical air control party. So my job was really deploying and setting up fiber and network switches and routers, and could be riverbeds, could be Cisco devices. And then our job was to harden those information assets. Could be a database, could be a networking device, could be an operating system, whatever it is. We would configure those and harden those so that they could process, transmit, and store confidential data. So that's a little bit about me. I've been in the DOD space really for the last 15 years. So we really understand the details that it takes to really authorize software in a regulated environment. Could be DOD, could be financial, could be healthcare. We're really in every vertical. So the agenda today, we're going to go over kind of the system authorization process and giving you the DOD context and kind of how the DOD is modernizing the authorization of software now. And we'll go over some of the aggregation techniques that Ignyte conducts in order to authorize software. So we'll show you how we gather components, how we build, collect, in order to define a system security plan, which is what the auditors and the regulators are looking for. And then we'll give a basic demonstration of the platform. We'll show you how our NLP works, how we map regulations across many different other frameworks, and then how we can map operational data to compliance data. I'll show you DOD Iron Bank. Iron Bank, if you're not aware of it, is the container hardening repository. We have a cooperative R&D agreement with the 16th Air Force, which is where we're doing a lot of this development in. And so we'll kind of dig into the vulnerability assessment tool, which is the VAT tool, which is really scanning multiple scanners in the Iron Bank pipeline, scanning the container images and runtime. Then we'll get into some future initiatives of the company and things like that. Quick question before I start: does anyone in here work in a regulated environment? Doesn't have to be DOD. Okay, awesome. Yep. And the thing is that the regulators are not going away. If anything, they're getting worse. And especially in the context of Kubernetes. The auditors and the regulators are trying to understand the technology a lot more. They're getting their hands dirty, and so it's just it's going to take some time for them. This is not a fast-moving process by any means, but as we continue to modernize, like I said, the regulators, they're just going to keep pushing and pushing, and so. Like I said, the purpose of this is for me to provide the developers, hey, this is what the regulators and the auditors are looking for. So I'll get right into it. System authorization, context of the DOD. You can see, pretty big problem, all right? Like, I'm not gonna get into this. If you have a month, maybe, I'll get into it. So you can see it's a systemic, fundamental issue with authorizing software. This is the Integrated Defense Acquisition Technology and Logistics Lifecycle Management Framework for software. Just authorizing software. I mean, it's pretty, yeah, I'll just leave it at that. And then this is kind of the risk management framework. So if you look up NIST 800-37, this is the logic that is built into our platform, but really this is the process that the DoD follows. Again, really nuanced process, something that really you shouldn't have to do for, cloud native technology. Doesn't have to be Kubernetes, can be anything. So our job is to simplify this for companies. And so all this logic is built into our platform, and we'll show that later. And then kind of the software factories that the DoD has been building over the last 5 years. So this was all spearheaded by the Air Force, AFCMC, Air Force Lifecycle Management. They built a platform, Platform One. I don't know if you all have heard of it. And a bunch of software factories throughout different, Air Force units have been building software off of Platform One. Platform One has a bunch of different service offerings that enable DevSecOps pipelines, and we'll get into that in a little bit. But really, how are we authorizing software? Is it a specific technology? Is it boundary defined? So like I said, are we accrediting a package that doesn't move, or are we accrediting a process? So that's really the main question, right? What is really continuous authorization to operate? And so really, the term platform often carries multiple connotations. So to clarify, I like to lay out a brief framework. So at the foundation, we have the infrastructure layer. This would be your AWS. I put in some secret cloud that the DoD is deploying. So I think everyone in here might understand the layers. So you got infrastructure layer and fences, which is another kind of secret cloud environment. So in contrast, this is, the zenith is where software factories and their respective developers are actively engaged in either developing or integrating to roll out capabilities. So that's kind of the goal here is we want the developers to just strictly focus on delivering features with minimal security control responsibility. So you can kind of see the platform layer. This is going to be the CNCF compliant Kubernetes distributions. I think the DoD uses mostly Rancher and Convoy. And then the CI/CD layer, this is where some of the Platform One service offerings like PartyBus, for example. PartyBus customizes pipelines for their clients. This can be custom pipelines, scanning pipelines, whatever the Air Force unit needs or our client needs, we build them their pipeline so that their application can meet stringent regulations. And so, the platform delivers, sorry about that. So all right. Sorry, all right, there we go. So again, kind of a layered approach here on how we're taking, software authorization. This here's the DoD DevSecOps reference design. You can Google it, but really this is kind of, high level how the DoD is deploying hardened container images and then deploying it to a production environment. So you can kind of see the data flow here. CNAP is the cloud native access point that includes things like Istio, Zeek for network monitoring and other things. I mentioned Iron Bank. Big Bang is kind of like a configuration as code, infrastructure as code mechanism. It's a Helm chart of Helm charts. It's basically just a massive repo of Helm charts for their tooling. And then kind of, going through the authorization to operate staging environment. CTF means certificate to field. It's just another authorization term in the DoD. And then the IL2, IL4, IL5, those are called impact levels. So those are secret cloud environments. IL2 is kind of unclassified. But this is kind of how the DoD is deploying software. And it's through this DevSecOps reference design. Really, the heart of it is really at CNAP, which is a Platform One service, Iron Bank, Big Bang. So those are all Platform One services that they offer to kind of streamline authorization and streamline the the hardening process and really streamline security. So, and I can go into detail on any of these highlighted areas here, but ultimately I want to emphasize that Ignyte really supports all of the leading cloud technology and cloud native stacks that the DoD provides, and really any open source mechanism that you've seen here at the conference. So we can integrate with all the common DevOps tools and computing platforms like the notable ones that you see. And then kind of another layered approach here. So control inheritance and DevOps in the federal space. Control inheritance serves as kind of the foundational step in the context of federal environments. So platform as a service is indispensable for achieving DevOps outcomes. The current tech discourse frequently mentions Kubernetes. It's really vital to delineate that Kubernetes isn't a platform as a service. As we know, it acts as a framework for crafting platforms. So when leveraging Kubernetes on an infrastructure as a service, one can only satisfy a limited set of controls. So this is stark in contrast to advanced platform as a service frameworks like the ones you see. There's some platform as a service that have deployed within the DoD that leverage this. So, and then SBOM component, software billing of materials. It's a pretty large, artifact that is populated within the pipeline. SPDX provides SBOM output. And that's kind of an artifact that the DoD is requiring for application teams to provide in order to give them kind of the recipe of what's in their application, right? Okay, so I mentioned the Big Bang platform. This is a example data flow diagram, and really, Big Bang, like I said, it's a declarative continuous delivery tool for deploying DoD hardened and approved packages into a Kubernetes cluster. Like I said, Big Bang, it's a Helm chart that is used to deploy DevSecOps platform on a Kubernetes cluster. And it's really, and we deal with like updating the Helm charts for all of their components. And then you have to cycle the Istio pods for each service. And so it's really a massive kind of Helm chart repository. So like I said, it deploys Git repository and Helm releases custom resources to a Kubernetes cluster that's running the Flux GitOps operator. These can be seen using kubectl, Git repository. And so really you kind of see the data flow. It has an ingress load balancer that's pushing 446 traffic. And then you have, I provided just some sample YAML on how the Istio operator is deployed, and Grafana, Prometheus, Jaeger, Istio, HH proxy, Istio and Envoy really for the service mesh. You see the DoD uses OPA. I think they're transitioning to Kyverno. They're monitoring Kyverno policies within the Big Bang cluster to, within Grafana. There's a Grafana dashboard where we monitor Kyverno policies to see if the Big Bang is, any of their components are failing any of those policy checks. So again, kind of high level data flow, but again, this is something that the DoD and really any regulatory environment is looking for any application team. They want to see the data flow. We want to see all the integrations, interconnections, and Keycloak. Yeah, of course, Keycloak. And we'll get into Keycloak in a little bit, but essentially, as a cyber guy, we want to look at all of the interconnections, and we know Keycloak provides access control mechanisms, and so we can certainly map that to compliance data. Okay, now some of the modernization with compliance as code. Now this is not OPA, this is not Kyverno, but this is an initiative that GSA and NIST collaborated on. It's called the Open Security Controls Assessment Language. Yeah, you can deploy it as a Helm chart. You can deploy it into any Kubernetes cluster if you're wanting to get compliance as code. But essentially, There's different components. I'm not going to go deep into OSCAL. You can look it up. There's a bunch of different models. We like the component definition model because it's purposely broad and flexible, meaning it is not very opinionated. So when it comes from a development standpoint, when you can define components in many different ways, so it encompasses supply chain, large organizations, to a simple policy or specific technical component around the software. But the first part of this is understanding the context so we can make it reusable. That's the purpose of this. We want to make compliance reusable because compliance is a hindrance, right? No one likes it. And so the purpose of this is to make it reusable, especially for application teams that are moving very fast. And I'll provide an output of OSCAL during the demonstration. Okay, so securing and configuring Kubernetes clusters. So Ignyte, we maintain the DISA Kubernetes Security Technical Implementation Guide checklist within the platform. I'll show you that in the demonstration. And then I just provided some links here. NSA, CISA provides the Kubernetes hardening guide. Iron Bank, scanning hardened container images, Big Bang, container security requirements guides. I'll show you that in the platform. But we are working and have completed the checklist. I don't know if Kubescape is here or not. I know they were in Tampa. But really, we're automating the entire process of scanning, remediation, and applying control statements for any distribution of Kubernetes. And then below here, I put the Kubernetes hardening guide. And then this is just kind of, it's a spreadsheet, but it's how we initially start gathering and automating these checklists within the platform. Okay, and now we'll get into some aggregation techniques. So with a plethora of components embedded in a modernized tech stack, each linked to a specific control, there's an envisioned future where these components can be seamlessly aggregated to form an initial foundation for a system security plan. As an information system security manager, I'm constantly in search of this foundational starting point, given my limited experience in software movement, right? We come from kind of traditional, we had to modernize our own tech stack a couple years ago. We were pretty monolithic on how the application was built, and so now we went from like no microservices to like 30 microservices, and when you see the platform, you'll understand why. So, but from a software engineering vantage point, challenges arise during control selection and tailoring. So hence, any detailed insights engineers can offer equip me with a considerable head start, right? So really, it's kind of a team effort. IA, information assurance, or cyber professionals need to work with the developers in order to meet regulatory challenges. And so further, with the ultimate objective lies in crafting components aptly as, encompassing elements like the Big Bang platform or an Ignyte app or a different component. And so this could range from classified environments. And so the real purpose of this is you can deploy in any environment. It could be classified, could be unclassified, it can be an air-gapped environment. It can really be any environment. And making it reusable. So the rationale, really underpins our commitment to component aggregation techniques. And again, I'll kind of show you how this is done in the platform. But high level, this saves time, money, faster initial system security plan delivery, runtime-based SSP, OSCAL will be your runtime-based SSP. And then reuse without knowing the target deployment environment. Okay, so our initial process. So as a dedicated cybersecurity and IA professional, my initial priority is to grasp the fundamental essence of the technology at hand. So this is not a mere box ticking exercise like how many of us think about compliance. It's not just box ticking. It's a meticulous process where we dive deep into understanding the foundational principles of technology and identifying potential threats, acknowledging security controls that need application, discerning the roles and responsibilities surrounding the technology, and lastly, comprehending the associated policies and procedures. So this is kind of our component aggregation process. Our first aim is to clearly define the technology and component, understanding its purpose, applicability, and the specific security controls it requires. So while some of the definitions are inherent, we've tailored them to suit public sector requirements specifically. And so you kind of see, in the build process, we're getting the component definition, we're getting the scope, right? Where is it deployed to? Who has access to it? Those kind of things. And in the security controls, this can be your FFIEC, CFPB, PCI for financial folks, DOD, or HIPAA, or Sarbanes-Oxley. So any framework you can think of, that's what we're trying to get here. And then really the component collection, the next step is assessing how many such components are into a single system security plan. So it's essential to classify these components, right? So are they technical, are they boundary defined, or designed around a specific set of controls? So concurrently, we conduct component aggregation analytics is what we call it, and it's a method where we examine the interconnectivity between components via URIs or other available data. This analysis is really pivotal as it offers clarity on how these components mesh together. So you can kind of see in the collect, we're looking at the type of component. Is it an API? Is it a stream processor? What is the type of component? And then we want to look at the interconnections. Is it connected to any external systems? Does it have to call to a database that's outside of their boundary? Their boundary could be AWS, could be Azure, could be GCP, could be whatever. And then we kind of, with the aggregation, control ID harmonization, harmonized by types, control ID and language. So we post the collection. So the collection phase, our focus narrows down to control IDs. So while NIST offers a standard, we have tailored our control IDs to cater to dynamic organizational nomenclature. So leveraging Ignyte's, we're a language shop. So we have a lot of linguistics that are built into the platform. So we employ language harmonization techniques to ensure consistency and control language, especially vital when considering the varied use cases between higher education entities and entities like the DOD. And so the end goal really is simplifying the ISSM's tasks. So if executed with precision, this approach facilitates the creation of a preliminary boundary diagram and aggregated harmonized language. And so the overarching intent is flexibility. The methodology might differ slightly depending on whether we're dealing with a software factory, on-prem technology, platform IT, weapons systems, et cetera. The context dictates our pace. And then reusable component definitions. So a salient aspect to emphasize its reusability. So when drafting components definitions, it's imperative to focus on their scope. So the lack of clarity here could impede the reusability across different scenarios. So successfully implementing this approach can save the organization an enormous amount of time and money. So as we refine our component building and language harmonization, we foresee further reduction in the time frame. So this work really could save the organization probably between 8 to 11 months of work. Okay, let me readjust here real quick. We will get into the demonstration. Change my settings real quick, sorry. Pull it up in 1 second. Okay. So here's the platform. Hope everyone can see that okay. Let me know if you can't. So this is kind of a standard dashboard view that we have. You can create dashboards and things like that. But I want to get into the language processing real quick because I know I mentioned a lot about the NLP stuff. So we do a lot of language harmonization, a lot of natural language processing, and this really helps us map across different regulations. What you're seeing here is the container security requirements guides. This is just an example of one. So the container platform must be built from verified packages, and so we map this to a NIST 800-53 control. So this is the control ID that I mentioned, CM5 enhancement 3. This is signed components. You can kind of see how the control description, the supplemental guidance, all that is provided by NIST, and then we map it to more technical guides like the container security requirements guides. And so we can do this a bunch of different ways. You can see we have a bunch of different pre-built regulations in our platform. You also customize regulations. You can create custom regulations. But first I want to show you how we map it. Since we're in the EU, there's GDPR, and we'll NIST privacy framework. So the bigger the bubble, the larger the amount of work. So that's kind of the goal here. So when organizations or application teams are looking at the amount of work that's required for each regulation, you can kind of see it here in our coverage diagram on the percentage of controls that are mapped across regulations, and then kind of the amount of work. So GDPR is a lot more work than the NIST privacy framework. But if we put something else that might be FedRAMP, which uses NIST 853 controls for their logic, you can see it's a lot more effort FedRAMP is compared to GDPR. Okay, and so we'll get into the aggregation techniques. But I just wanted to show you that real quick because we are a linguistic shop. We do a lot of language processing and a lot of mapping between regulations. This is kind of the heart of the company. This is our core. This is what we do. We do compliance mapping. It's very boring, but it serves a lot of purposes. So we're trying to make compliance cool, right? So, but like we have different ways that you can map frameworks in here. You can do it manually, but this is kind of our process, right? You can map it that way. So kind of a really intuitive mapping engine that we have built into the platform. Okay, so we'll go into the aggregation techniques. You can kind of see my workflow here: build components, collect components, aggregate, initial SSP, and so on, right? And we kind of have all of our components here. If you're not aware, Azure OpenAI actually got FedRAMP authorization like last month, so really surprised with that. We have NVIDIA CUDA containers that we're looking at. So I'll just we'll go into Azure OpenAI. And really the brunt of the work is done here in the requirements section. This is where the regulations are at. And you can kind of see, we'll go into a control here. And it's really just really intuitive for the end user. If you want to put in your comments for a specific control, you can. And then it's custom. So you can customize all the organizational defined parameters that are defined in NIST. This is all NIST language, and you can come in here and edit it as needed. If there is a vulnerability, we can mark that as a POAM, and it goes automatically into this POAM section. And that's for tracking, remediation, and things like that. If you want to categorize the system, let's say you have a specific information type, you can categorize this is, and then again, this is all logic from NIST. So this is NIST 800-60, FIPS 199. All the logic for this categorization stuff is all from there, and we just built it into the platform. But really, if we save this, you can see all of the information types that are defined in NIST 800-60 are baked into the platform. So if I just select just a random one, it'll populate your categorization for you because FIPS 199 defines that for us already. Okay, so that was just one component. And then you can see in video, we're using the container SRG here. Azure OpenAI, we're using NIST RMF Rev 4. If you want to add a system, okay, we won't go through that. But we'll go into NVIDIA real quick, just to show you what the container SRGs look like. And so these are the container SRGs. And as I showed you in the mapping engine, we can map all these to specific regulations. Any regulation you can think of, we can map this to. And same thing, if something is marked deficient, we can put it into the deficiency register for tracking. If you want to upload an artifact, you can upload it in our artifacts module. But really, like I said, the brunt of the work is going to be done in here. And then as we go through the process, we're building, we're collecting, and then we aggregate. I'll go into the GDPR real quick, just so you can look at the GDPR requirements. And so these are kind of the GDPR requirements, pretty broad, right? But just wanted to show you that we do have all of the GDPR requirements in here as well. Okay, so back to our process, aggregation process. Go into the Civo Big Bang. And we can also do tagging. So if we want to say, hey, Istio our key cloak is doing account management, doing some of our automated system account management. Istio Envoy is doing some of our access enforcement, information flow enforcement. Elk is doing our account monitoring, things like that. So really custom tags that you could put into here to say, hey, this component, this is their responsibility for this part of the system. So that's kind of how we conduct our initial process of building, collecting, aggregating, and then kind of pushing out an initial system security plan to the regulators. And then I will show you an example. So, but you kind of see it, all the components that we're collecting that make up the platform, right? From that data flow diagram I showed you earlier, these are kind of the same components. And then once we go into here, we can go into reports, can download the compliance report, and it'll show you all the systems that you can download the report from. So if I click that, it'll spit out a YAML, and this is OSCAL. This is the Open Security Controls Assessment Language, so you can see we have our component. We have our component definition up here. It generates a custom UUID. And then you can kind of see, Istio control plane. It's the source. Source is coming from NIST 800-53. And then how Istio is conducting request authentication and authorization for really authorizing information flow pertaining to who the user is. If the user doesn't have the permissions, then Istio or Kyverno will not allow that user to either access that domain. And so you kind of see it, it's a very, very long YAML. But in order to create reusability for authorizing software in any regulated environment, this is the way forward, I think, with OSCAL and component definition models specific to Kubernetes environments, cloud native environments. We talk about LLMs a lot in large language models now, so we're starting to get into large language models and assessing those at a granular level. What are the containers that are running in there? So going back, I know I only got 5 minutes here, but I wanted to hit on Iron Bank because I said I would show it to you. So this is just one example. I mentioned NVIDIA CUDA. These are all their vulnerabilities. You can see the different layers, their Python layer, their UB image layer here. So this is Iron Bank, and then eventually we're going to put these into the pipeline issues, and within here, we'll be able to remediate container vulnerabilities. But this is part of our CRADA agreement with the 16th Air Force. This is something that we're still developing. Also something that we're not able to share, unfortunately, within the open source community yet. We're trying. And then I also want to get into security content automation protocols. So the Navy has a tool called the SCAP, Security Content Automation Protocol, and it's automating all those STIGs that I brought up, the container security requirements guides and things like that. So we actually have a license agreement with the Navy on the SCAP tool because the Navy isn't funding it anymore, the DOD isn't funding it, so we took it and now it's baked into our platform. And so you can see this is the Ubuntu STIG, and then you can see it's going through its pass and failed checks and things like that. And then we can also link this to the compliance systems that I just showed you earlier. So it's really a robust GRC platform, or however you want to call it, GRC, Integrated Risk Management. And so yeah, that's kind of how we can map operational data to compliance data, is this way. And going back. Okay. All right, so our future initiatives is to optimize FedRAMP small business assurance cases, and we really think containers are the way to go there. Some of the things I just showed you on. And then existing CRADA with the 16th Air Force I showed you, Navy SCAP component development, and then open source component collaboration. So we do have a Helm chart. If you want to reach out to us, we'll be more than happy to talk to you and supply you the Helm chart if you want to mess around with it. But we are containerized. It's just a lot of political stuff. With the CRADA agreement, we can't produce some of it yet. But it is in the works, and as you can see, we're already doing a lot of the hard work out there with mapping this stuff to compliance regulations across many different regulations, as you can see. So I got 2 minutes. I apologize. Any questions? Yes, sir. Ramiro.
It was really interesting to see on Big Bang how many open source projects are being used.
Yeah.
It was really interesting. How does these highly rated environments dealing with like all the vulnerabilities that this large open source projects have? Are they cleaning them for themselves? Are they just using the base images and take the risk? Like for something like Prometheus, for example.
Yeah.
How do they deal with it?
Yeah. So Iron Bank takes the Prometheus base image, and then they harden it through the container security requirements guides that I showed you, and then they'll make it their own. They'll call it Iron Bank Prometheus image. And I was, Iron Bank has their own issues because there's things like ChainGuard out there, and ChainGuard has their own images in Iron Bank as well. But yeah, that's kind of how they do it. They grab the base image, they harden it, they put a hardened image on top of it. It could be a UB8 image or whatever, a FIPS enabled image to meet the requirements. But yeah, that's kind of how, and then they put it through their own pipelines before they push it to production. So awesome. Thanks for the question, Ramiro. Okay, well, thank you all. I appreciate you attending.